Hello everyone and welcome back to the channel. In my past two videos, I have covered simple linear regression and the transition to multiple regression analysis in Excel. In today's video, I am going to be covering the most important metrics by which you can evaluate your model in Excel. And these metrics are very important to understand. But before we dive right into it, do not forget to subscribe to my channel for the latest of data analytics across different technologies. At the end of the video, there will be a bonus quiz as well, which will help cement your understanding and test your understanding of these concepts. So do stay tuned to the end and see if you can solve the bonus quiz and test your understanding of these concepts. So let's get right into it. So the three important metrics that we evaluate during our regression analysis are the multiple R, the R squared and the adjusted R squared. Now let's take a look at each one by one because it's very important to understand them. And it can get a bit confusing at times, but they are very simple. So let's take a look at multiple R. So multiple R is nothing but the correlation coefficient. So this represents how strongly correlated are your dependent or the target variable with the independent variable or the predictor. How strongly correlated they are to each other. So if you go back here and you remember in the multiple regression analysis video, if you have not seen that, do take a look at that. But we had found this correlation chart, and this correlation matrix identifies the correlation of each variable with the other variable. So here you can see the correlation between miles per gallon and displacement. They are very strongly correlated. It is minus 0.8475. That represents an inverse correlation. So if you see this number, it is same as the number here. Only thing, multiple R doesn't represent the direction of the correlation, but it just shows the strength of the correlation. So this shows your correlation coefficient. Now let's move on to the next. What is R squared? R squared, this is a very important matrix. This helps determine how much of the variability of your Y variable or your target variable or your dependent variable, they are all the same, how much of the variability of your dependent variable can be predicted or can be explained by your independent variable. So in this case, in a simple linear regression model, our target variable was miles per gallon and our predictor variable was displacement. So how much of the variability in miles per gallon can be explained by displacement? So in this case, 71% of the variability, 0.71, so 71.8% of the variability in the miles per gallon can be explained by the displacement in this case. Okay. Now you may ask, what is adjusted R square then? So adjusted R square comes in the case when we have more than one independent or predictor variables. So as we saw in multiple regression, when we move from simple linear regression to having more than one independent variables used to predict your target variable, like displacement and horsepower we use, then we use adjusted R square. So why we use adjusted R square here? Adjusted R square actually penalizes your model if there is no significant improvement in the model fit by adding an extra variable. So that is why we discussed that very carefully in the last video. If you have not watched, do take a look at that as well. That by adding more features, you should be getting a better fit of the model. Otherwise, there's no point in adding more features. And if you're not going to get, then adjusted R square adds a penalty for every feature added that does not improve the model's predictive power, or the feature doesn't have a good predictive power to improve the overall predictability of the model. So let's take a look at that as well. So we had generated the statistics for the model here, if you remember. So R square is 0.748. That means in this case 74.8% of the target variables can be explained by the dependent variables, and the adjusted R square is 73.0. So it has gone slightly down, and we discussed the reason as well, because we have used two variables which are highly correlated with each other. That could be one of the cause. So always make sure you are not using variables that are strongly correlated with each other, because you are embedding the same information in the model, and be sure to use variables that improve the predictive power or the overall fit of your model. I hope you have understood this concept. Now let's test your understanding of this concept. As we discussed, there's a bonus quiz. In my previous two videos of simple linear regression and the transition to multiple regression, I would encourage you to watch them and try to identify a tiny mistake in those videos. If you have managed to identify the mistake, take it as a test for yourself and leave a comment in this video. That will help cement your understanding of these concepts and ensure that you do not get confused with these concepts. Do watch the videos as many times as you want, but I encourage you to try and identify the mistake to help to help ensure that you have understand these concepts very carefully, and it will help you in your machine learning journey along the way. Do leave a like on the video and don't forget to subscribe to my channel for the latest of data analytics across different technologies. Until next time, thank you.